Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is the first in a long series of videos. So, as you are familiar with, there's something called the 100 Days of Code deal. And basically, the idea behind 100 Days of Code is to make a sort of a promise to yourself that you're going to practice code every day. And what you do is, like, every day you document sort of a thing you did code wise. One of the things that I'd like one of my personal goals is to get better with the Go and Rust languages. Like I'm fairly super confident in my skills with JavaScript and pretty confident with like Ruby and Python and PHP. And I'm decent in Go. Rust I could definitely use some more work in. So I figured I'd really like to get good at these two compiled languages. So what I'm going to do is I'm going to do 100 days of Rust and Go video series. Okay, same idea, 100 days. I'm going to practice Rust and Go every day and make a video about what I practice. So these first few videos are going to be stuff that I already know, so it's going to be more of the teaching style that you're used to. But eventually you're going to get to watch me sort of look through documentation, sort of figure things out as we get into sort of beyond the surface. And yeah, again, these two languages kind of are different in a lot of ways, but fill a similar sort of gap in the market in a lot of ways, in the sense of trying to create a language that's sort of faster than the interpreted languages, Python, Ruby, JavaScript, but a little bit more friendly than the old school compiled languages, C, C++. Both of them are more like, I guess, trying to sort of be an alternative to C-ish. Go, not as much. I don't know. Like Rust, I guess, is the faster language, and you'll see why as we start getting into the guts. But it also makes it the more complex language, because it does try to do things in sort of a way that no other language does it, with those whole like borrowing and ownership syntax. But they are both faster. So why Go has become super popular for making like a lot of, you know, web services that require faster, while Rust has been really popular for making a lot of sort of like runtimes, more systems level stuff. So making Deno, for example, is built in Rust. But yeah, the thing is that they're going to have a nicer environment for managing packages, much more straightforward workflow versus like C and C++, where you have like different compilers and different libraries are built to work in different compilers, and there's different package managers, because a lot of those things just didn't need to exist when it was created. So just kind of like you ended up with sort of like chaotic environment developing. So while again these are things that were thought in the process of creating Go and Rust, I think Rust definitely thought through the package manager thing a little bit more than Go did up front. Although Go's come around and really kind of made that much more streamlined than it was. Um, but they're just going to be like nicer to use. So in the same way, like Node is such a Node and JavaScript is such a pleasant experience as a developer. These try to bring that to sort of more lower level compiled languages. So in this video, what I want to do is just make sure that we have our environment set up. So I'm going to be using Visual Studio Code for the most part, and I made a folder called 100 Days of Rust Go. Okay, and I'm going to create two directories, and that's going to be one for Go and run for Rust. Okay, and I'm going to open up a terminal in Go. And first thing I'm going to do is just check, hey, do I have actually Go installed? Okay, I'm not going to walk through the installation of Go, so Google how to install Go in your operating system, because again, things differ from operating system. Just go on Google and just say install Go on Windows, install Go on Ubuntu 20.04, or install Go on Mac OS, whatever version you're on. Now you get the best guide to get you all set up. Okay, but then I can just do, I think it's just in Go, I don't think you even really need the dashes. I think I can just do Go version. Is that correct? Yes, I can. Okay, now I'm going to just make sure that I'm up to date. I don't think I am. So I do have a script that updates my Go that I got off GitHub. ls, where do I have those? I think it's in like a folder called scripts. There we go. CD scripts. create.net, update Golang. That's what I want to do. Okay, so I want to run update Golang. Oh, put the CD into it. That's the folder. Okay, let me go here, and there it is. Update Golang. I'll just do source update Golang. And what this is supposed to do is this is going to, it automates the whole process of like getting the newest version of Go, unpackaging it, putting the folders in the right directory, deleting the old files. Because at least last I checked, Golang didn't have like a built-in way of updating. You'll see like Rust has Rust Up, which is kind of like their version manager, kind of like Python version manager or Ruby version manager or Python version manager that can help you switch between versions of the language, which is really nice. So if I do that, that's going to go. No, that's not good. Okay, let's try that again. Glad I just didn't break my Go install. Okay, let's see here. CD scripts, CD update Golang, and then I'm going to do. Let's actually just do it. Update. Permission denied. Okay, I guess it wants me to use sudo. Although I'm not that far behind version-wise, out at 1.16. Newest version's 1.17. So let's just do that with sudo, so it can just do its thing. Okay, so it's doing its thing. That's going to update Go. So I'll give that a second. I'm going to open up Rust in the terminal. Run terminal command. Nope. Run open and integrate terminal. Here I can check the version of the compiler, Rust C --version 1.5. But more importantly is Rust Up. Rust Up version. Okay, let's remember the different commands. But let's see here. Rust Up show the active and installed toolchains or profiles. So I guess that seems to be what I want. Rust Up show. Okay, so these are the different versions of Rust that I have installed. Okay, so see, nightly, there's different versions of Rust. Like there's like the stable, which is like sort of the most recent stable version, which doesn't update quite as often. Then I forget what the middle one is, and then nightly literally updates each night. So it's basically like the update of the repo from each night. I think I'm currently defaulting to nightly because I was using it to do some work in Rocket, which is a web framework in Rust, which requires you to be using nightly. Okay, but that's what they mean. So like the names actually imply like sort of like how regular the release is. So nightly again is the nightly release. Like let's see if I can go look up the different Rust versions. Okay, so Rust Up versions. Okay, the Rust Up book. Tool chains, channels. I think it's right here is where I'm looking for. Nightly availability, but what are the other ones? Okay, Rust not activated, blah blah blah. Okay, tool chains. I think this is maybe what I'm looking for. There is channel. There's stable, beta, nightly. So stable again is the most recent stable release. Beta is the most recent sort of beta release, meaning like it's a candidate to become the next stable release. Nightly is literally every night. Okay, which is kind of cool. Okay, so let's see here. Rust up -- help. Actually, let's do just Rust up help. There we go. So take a look at the commands. Check. Default, set to default chain, tool chain. Target. Okay, I want to say Rust up which. I'm just wondering which one am I currently using? No. How about this? Rust up update. Let's just do that. Just gonna update everything. Last time updated was back in, well, today, July 29th. Okay, so that's gonna update that. Let me just see how Go is doing on the update. Just that way I'm working off the most recent versions. Okay, I think that is all updated. So let me close that window. Let me just make sure I'm not missing any. Yep, there it ran hello world. So that should be good. So if I go to Go and I open up a new terminal, And I type in go version. Yes, we're update. Okay. Cool. So let's just show you how to do like hello world in Go real quick, and then we'll continue this in the next video. But and then again, if you want that update Golang script, it's on GitHub. Just look up like update Golang on GitHub, and you'll find that script. One of the cooler scripts I found on GitHub. Okay, in Rust again, if you use Rust up to install Rust, it will be good to go, and you can just update it using the toolchain, which is super nice. Let's see how it's doing. Okay, and if I do, okay, so now I'm all updated on the different versions. Let me just do one more check. I just really want to confirm which one am I currently using. Help, completion, set, settings, toolchain, modify or query the installed toolchains, target, component default, set the default toolchain. Let's see here. Rust up check. I'm up to date. Next toolchain. And self completions. Run. Toolchain. Target. Component modify toolchain install components. Let's see if I just do Rust up default. Rust up default will just show me what the default is currently. Okay, stable. Okay, that's fine. We'll use stable for now. Okay, no need to get into the bleeding edge and nightly features for at least for the first several videos in this series. Okay, so let's make a file in both. So let me go open up Go. Let's go to the Go terminal. Let's get this out of the way. Can use 100 days of Rust and Go. Okay, and in this case I want to make a touch, run.go, just a basic Go file. And there's a couple different ways I can do this. Like, I'll go open it up and edit it. And both of these are compiled languages. The thing about compiled languages is they require you to wrap everything in a main function. Okay, because the idea is that every program you run is really a function. Okay, and the way most compilers work is the main function is the thing that's being run when you run the executable. So then everything gets run from within the main function. You might define them in other files, but the first thing that gets executed, the first thing on the stack, is going to be your main function. So in Go, what I want to do is first I want to do a package, and generally if you're not really have a package, you just do package main. Okay, it'll complain, whatever. And then I'm going to do import, and all I really want to import is FMT, which is part of the standard library. That's like where all your printing commands and all that stuff to print to the console are. And then what I want is the main function, which func main. Okay, and then all I really want to do is FMT, because anytime you import a package, you always have to use the package name first. FMT dot println, and this you get used to this. Anything that's exported from another file has to be uppercase. That's how you don't use hey, export this, don't export that. It's capitalized, it's exported. If it's lowercase, it's not. That's the convention here in Go. So fmt.println hello world. And then you don't need semicolons in Go if I remember correctly. Okay. Well, again, I'm going to ignore that error for a moment. Let's just try to run this. Now if I just want to run the file real quick, I should be able to just do go run.go. So go run the file. See, and there it works. Now later on you'll see we're going to have packages and have multiple files running. Then what you do is you would do go run dot. It's going to run everything. It's going to compile everything in the folder and run the main function. Just you can't have more than one main function in the folder. Okay? So it'd be go run the directory. And then I could also build it to an executable. So I could just say go build run.go. That's going to build the executable. And see, there's the executable. And then I could be /run hello world. And it runs the script. Okay, so that's pretty straightforward. That's what I like about Go. It's very, very friendly for a lower level language. Okay, like if you compare it to like working with like JavaScript and Python, it may seem like it's got a little bit more work. Um, but if you've worked with like C or C++, this is much, much, much pretty straightforward. Okay, now let's go to the Rust terminal. Get a little bit of these. Okay, now here in Rust, okay, if I just have, there's two different ways to kind of run files. It depends, are you running a package, like a whole like project? Then we're going to use Cargo, and Cargo is like the NPM of the Rust world, and we'll get into that in later videos probably not for like a good 10, 15, 20 videos, because I really want to kind of focus on just like the core language and the standard library and getting familiar with it, because I haven't really spent that time with the core. Like I've played around with lots of different things, but I haven't really like spent that time like I've done with like JavaScript, Python, where I just like learned the fundamentals. So let's make a file. Okay, and so in the same way that like Go files had that Go extension, Rust files are going to have an extension of rs. So we'll just say run.rs. Okay. Now, if you just want to run a single file, you just use the Rust compiler, which is Rust C. Rust C for compiler. Cargo again is the package manager, but you have to create a package and then you can run it. That's a little bit more complicated. Not that much more complicated. It's just we'll get there. So here we go. So if I want to first make a file, and then I'm trying to remember if I have to import anything or write anything. I think here I can just really just write define the function. And in Rust, notice how like in Go a function was defined with func. In Rust it's defined with fn. But it's the same story of main function. It's a compiled language. It's always the same story. Okay, and then Rust doesn't I mean, it has a print function, but the idea is that like Rust is all about safety. It's all about making sure that like everything is perfectly typed and you're only ever allocating the memory you have to. So everything has to be sort of very rigidly typed. Okay, there's very little bit of like dynamic figuring things out. Because the problem is when the computer has to figure out things for you, it generally has to allocate more memory than it needs to make sure that it's got you covered. And we're trying to avoid that so you can make faster programs. Now, because they're trying to avoid having a garbage cleaner like you would in Python, Ruby, or JavaScript, but they're also trying to avoid the fact that you would have to like allocate everything manually in like C. Okay, which can, if you've ever done that, and I've done a video on that, it can be not fun. Because then you have to allocate the memory, then you have to copy whatever to the memory, and then once you get out, when you're done with it, you have to actually go in there and deallocate the memory. Not fun. Okay, while the garbage cleaner in Python, Ruby, JavaScript, it just is constantly running and looking for unused things and cleaning them out, but that's just a thing that's running and slowing down the whole process. So Rust tries to find this sweet spot, but because of that, everything has to be sort of very strict. So what it does to make your life easier, because if I wanted to use the print function, it's like a different, basically I have to see, like, does this thing have this trait plugged in? There's a lot of things I'd have to figure out. So what they do is oftentimes when there's like a complex bit but boilerplate code, what they do is they create these macros. Okay, and you'll know what they are because they generally have like an exclamation point at the end. So they're not really functions. It looks like a function. So if I do print like this, okay, it looks like a function. Okay, but really what happens is that the compiler will pick up on the exclamation point, and I think I did that right. Okay. I always forget if it's lowercase print or uppercase print. We'll find out in a second. It picks up on these macros, and then what it's going to do, and there's going to be other ones that have like hashes in front of them. There's different situations. Actually, the more I'm thinking about it, the more I want to say this is lowercase. Okay, and then it's going to fill in that piece with sort of the boilerplate code. Like it's going to run a function that doesn't necessarily run at runtime. It runs at compile time and replaces the code with something else. And you'll see this a lot in Rust, where you use these macros to sort of replace code at compile time. Okay, these are kind of like compile time directives in C or C++, but you can do a bit more with them, and they're pretty cool. Okay, so Now what I want to do is just say hello world. So I can just type in the string hello world and we're good. Okay, cool. So if I do that, and then what I do is I first have to compile the file. So unlike Go, there isn't really like a run command. There is once we start using Cargo, but not when you're using the Rust C compiler that I'm aware of. Let me just double check. Rust C, because again, these things do get updated. Rust C help. Okay, how about this? Rust C dash help. There we go. Let's see here. G file name out warn run. Yeah, it doesn't look like it's like a one just a quick run kind of command. Cool. Yeah, that's fine. So basically, you would just do rust c, then the name of the file, so run.rs. .rs, and see that generates the run script. And then I can do this. I can be like /run and run the file, and see there's hello world. Okay, so that's basically how that works. So we know we have Go and Rust installed. They're up to date. Again, Rust is installed using rustup. Go you just install based on what you look up. Easy way to update is using that update Golang script, so I recommend picking that up. And yeah, so there's the basic setup for this first video. And we're just going to keep doing that. So we'll just learn things and keep trying them out in both languages so we can see these back to back. Because I find both of these are going to be a skill that I want to have, and hopefully you'll want to have them, and you're watching this video series because of that. So I'll see you all later. Have a great day and enjoy. And make sure to join the Slack community and Discord community over there at devnursery.com as well. Like the video, subscribe, follow me on Twitter, Alex Merced Coder. Have a great day.